Okay. Um, Now we're going to shift from future value to present value. We're going to do the same type of calculations. We'll do the present value of a lump sum, which is the opposite of the future value of a lump sum, and then we'll do the present value of annuity as well. So, so present value. Present value is the value today of future cash flow or series of cash flows, and that can be a lump sum. We discount, which is a process of finding the present value of future cash flows or of a future cash flow or series of future cash flows. Um, Finding the present value is the reverse or the inverse of finding the future value, which is compounding. So, so discounting, compute the present value of an amount, we bring it back to the present, and so when we're comparing, numbers, more is better. So here, so we would take our $935. I'm sure it's going to. There we go. All right. So we take our 935 and we divide it by 1.1. We divide that by the 850 by 1.1, and we get 772. So this would be the timeline methodology. So each of these are divided by 1.1 gives us 702.48. So what that tells us is with our 10% opportunity cost or rate of return, that the $935 is worth more than the $700 because the we got when we did the future value calculation, we did 931.70. Here we got 702.48 versus 700. So the that $935 is tells us that the $935 is if our rate of return, required rate of return, is 10%, then that is worth more than receiving $700 today. Um, so the formula for the present value of a lump sum is just, if you recall, our future value is equal to the present value times 1 plus r to the n. So we can do a little algebra. So we would divide the 1 plus r squared by both sides, and we get our new formula, which is the PV, or present value, is equal to the future value divided by 1 plus r squared. So the just ignore this. I don't understand why you even need to do that. I think it just makes it a little more confusing. But with our example, take our $935 and we divide it by 1 plus the interest rate to the third power, and we would get $702.48. If you wanted to do use a formula in this case, you would use the y to the x key. This would be 1.1 y to the x 3 and equals, that would give um, um, and you would divide it's the same number if you were calculating the future value of the $700, but the y to the x key is above the 9. But then you would need to want to divide this. It would be 935. Oops, 935 divided by this number, and that would give you the 702.48. On the using the calculator, it's going to be we got 3 years, which and 10% opportunity cost rate, or required rate of return, 10 IY. So 3N 10 IY. We're calculating present value, but no payments involved. So we got a 0 for payment. We 935 in future value, and we compute PV, and that's a negative 702.48. So that's there. It's negative because that's the way the logic in the calculator works. This 702.48 would theoretically be an outflow, and then this, or the receipt of this 935 would be an inflow. Present value of an ordinary annuity. Again, ordinary annuity is the default for the calculator. So the present value of annuity with you know, any number of payments. We can, doesn't matter. We can calculate any number of payments that we need to. The each payment is discounted. The sum of the payments is the present value of that annuity. We go back to our previous example. So we had $400 ordinary annuity at 5 or for 3 years at 5%. So the first payment is received in 1 year. So we would divide that $400 by 1 plus the interest rate, 1.05. 400 in the second year, 400 divided by 1.05 squared. And then the third period, 400 divided by 1.05 cubed. So the present value of that annuity would be $1,089.30. We can enter that into the calculator. Next I'll show you the formula. The formula in this case, we're getting to get a little bit uglier. So it's our payment multiplied by 1 minus 1 divided by 1 plus the interest rate to the n power divided by the interest rate again. So what does that look like so we have our $400 multiplied by 1 minus 1 divided by 1 plus the interest rate, or 1.05 to the third power divided by 0.05. If you like using formulas, I would highly recommend that you get a graphics calculator. It is much easier to do these calculations. But using the formula, same number, same result. The present value of that annuity, $1,089.30. And then finally, using the calculator, the simplest way to do this, we've got 3 years, 3N, 5IY, calculating the present value, $400 payment, and then 0 future value. And then we type compute PV, and we get a negative $1,089.30. So we could also use the cash flow function in the calculator. So I will show you that on at the beginning of the next example.